Hey, guess what, Rockheads? Progress Telerik wants to send someone to build. So they're having a contest. Step 1 is to sign up and learn about the new innovative modern UI tools they'll be announcing at Build. By registering, you'll be entered to win a full conference pass to Microsoft Build plus a $500 travel stipend. They're also giving away 3 Telerik DevCraft UI licenses. And for .NET Rocks listeners, they'll also be giving away a Telerik DevCraft UI license every week. All you have to do is register at buildcontest.pwop.me. That's buildcontest.pwop.me. Progress offers the leading platform for developing and deploying mission-critical business applications. The creator of the award-winning Telerik.NET and Kendo UI, JavaScript user interface components and controls, reporting solutions, and productivity tools, Progress offers all the tools developers need to build high-performant, modern apps with outstanding UI. Go now to buildcontest.pwop.me and sign up to win. Welcome back to .NET Rocks. This is Carl Franklin.
And this is Richard Campbell.
You know, we were just talking about XKCD, weren't we?
We were.
Yeah. I love that comic, and I love Randall.
Randall's awesome. We had the good fortune to interview him. Very interesting character.
Yeah. What I've got for Better Know Framework is an XKCD cartoon, which I'm going to attempt to narrate.
Awesome.
So roll the music.
All right, dude, make your attempt.
This is number 1949. So if you go to xkcd.com/1949, Fruit Collider.
Like the Large Hadron Collider, only different.
Exactly. How new types of fruit are developed. And there's somebody, a stick figure at a board, pointing to some sort of explosive explosion here. And it says, when 2 apples collide, they can briefly form exotic new fruit. Pineapples with apple skin, pomegranates full of grapes, watermelon-sized peaches. These normally decay in a shower of fruit salad, but by studying the debris, we can learn what was produced. Then the hunt is on for a stable form.
Now, the trick with an XKCD is you have to hover over the picture because the text is always brilliant.
Yeah, that's right.
Right? The most delicious exotic fruit discovered this way was the strawberry banana. Sadly, it's only stable in puree form, so it's currently limited to yogurt and smoothies. But they're building a massive collider in Europe to search for the strawberry banana that can be eaten whole.
Yeah, that's the tool tip.
It's the tool tip. Genius.
Genius indeed.
Miss you, Randall. Come back on the show, man.
Yeah, Randall Monroe for president. Oh, maybe not. Who's talking to us, Richard?
We haven't done a show on concurrency for a while.
Yes.
And I'm excited to do it, all stoked. But you got to go grab a comment that's relevant. And I know it's also Riccardo's first time, so I can't go back to one of his past shows. The show that I landed on was 1203.
Huh.
So this is a show we did with Michael Van Sickle about programming in Go, which on the surface you think not necessarily concurrency, except that so much of development in Go is based on the actor model, which is totally about concurrency.
Right.
And there's just a ton of comments on the show because lots of folks were interested in the actor model and concurrency and so forth. And I'm just going to grab this comment near the top. This is Philip DeBecco, who says, interesting show. I have developed clustered and distributed systems for years, and it seems that distributed systems has won. The main reason, in my opinion, is that clustering is just too hard to make right. For clustering, one has to maintain shared state, synchronize configuration, handle endless failure cases. Distributed systems are generally built on a different concept, no shared state, and really no shared anything. Thus, while they're initially harder to set up with the asynchronicity and no single state means you have to distribute across different nodes and so forth, they are ultimately easier to develop. Interestingly enough, the same thing has happened in programming models. Instead of threads with shared memory, we now have message passing, whether the actor model or others, and the main reason is the same. It's just easier in the long run.
Yeah.
Yeah, I'm not going to argue with that.
Nope.
I would argue that the clustered approach was more memory and resource efficient. The distributed port less so. But we've got enough resources, so it's not a big deal to be a little quote-unquote lazy with it because reliability is actually the more scarce resource.
Yeah.
So, Philip, thank you so much for your comment. A .NET Rocks mug is on its way to you. And if you'd like a .NET Rocks mug, write a comment on the website at .NETRocks.com or via any of our social media, because we publish every show to Facebook and Google+. And if you comment there and we read it on the show, we'll send you a mug.
And definitely follow us on Twitter. He's at Rich Campbell. I'm at Carl Franklin. Send us a tweet. We read them all at once. All at the same time.
We read them asynchronously. It may not be exactly the same time, but
Quantum tweet reading.
I'm not going to finish reading your tweet before I start reading his tweets.
I've already finished. I'm sorry.
Let's just do concurrency jokes for the rest of the hour. How about that?
Riccardo, it's okay if you want to just like go boo or something like that. You don't have to stay completely quiet.
You don't have to hold back on us. We're badly behaved.
All right, well, let me formally introduce Riccardo. Originally from Italy, Riccardo Terrell is a seasoned software engineer and Microsoft MVP who's passionate about functional programming. He's active in the .NET community and author of Functional Concurrency in .NET, which features how to develop highly scalable systems in F# and C#. Riccardo believes in polyglot programming as a mechanism for finding the right tool for the job. When not at his desk, there's a good chance he's walking his pugs. Those are dogs, by the way. Sipping a good Italian wine, as I am right now.
Nice.
Or cooking for his wife. Yes, I have a Col di Sasso Toscana Sangiovese.
Ooh, Sangiovese.
Right in front of me.
Yes.
Very civilized.
Very, very civilized. I thought I would try to do the bit method, the method acting.
So you got fully in.
I got fully in.
Nice.
Here you go.
All right.
Just for you. Ready? Ah, that's wonderful.
Oh, impressive. Anche smell it.
Mm-hmm. Okay.
Don't think that's true. That's getting a little weird there, but okay.
It's a little weird. When have you known .NET Rocks to not go weird?
Not a little weird. A little bit weird.
So concurrency has been something we've talked about on this show ever since episode 1, I believe, whether it's concurrency in data or concurrency in the language, using threads, using the original .NET asynchronous pattern, then the task parallel library and parallel for and loops and things like that, and then async await. Things just keep getting better and better, and now
concurrency everywhere.
Yeah, now I can't tell you the last time I had to spend any time on plumbing code around async. Like, my async code with async await, or maybe I have to kick off a thread, but the stuff just works for me.
Yeah, sometimes I heard, somebody tell me, I parallelize my code and run twice as slower. Well,
that's right.
Probably you need,
There's a joke that we have about Outlook, which is, the Outlook desktop application tends to really hang up and it's really slow, and you look and see what it's doing and there's like 60 threads.
Oh, yeah.
60 threads, not one of them for me.
Yeah, Outlook's there. But also even Notepad is miserable. You have to check, in the task manager, how many threads just for Notepad.
Right.
Why does Notepad need threads at all? I just don't.
Beyond one to exist.
Yeah, exactly.
Really? That's crazy. So anyway, where do we start with your story and concurrency?
Well, we're going to start. Well, I think that since last time was using .NET, concurrency, you're right. I think we start with, 1.1, I think already? From the beginning, we have a synchronicity available, right? And we saw how evolve over time, from, as you said, the APM, then there was like the event asynchronous pattern.
Yeah.
So there was the evolution from Microsoft over time, but it was not quite there yet, right? So recently, as you said, we have the async await that make the life easy for everybody. However, there are still, some problem with that. I think that should be nice to know how to solve them. Like one thing that talking about the async and await is the fact that it run immediately, right?
Yeah.
And developer, they don't know how this is work underneath it. It just use it. But there are, some problem because you can now run in parallel. I mean, it's not trivial how you can run in parallel multiple asynchronous operation, right?
Sure.
Yes.
And so you need to know what you're doing. Otherwise, as I said, you think you parallelize the code, but actually run, twice as slower, because even asynchronicity is not about speed, right? It's about scalability. It's making your system more scalable,
right,
and able to cope multiple requests over time. So yeah, synchronicity definitely is probably my favorite programming model, because one feature about synchronicity is the fact that allow to developer to unbounded parallelism.
Unbounded parallelism?
Yes.
That's a new term for me, I think.
Well, let me tell you more. Like, for instance, you have a different kind of operation, right? You have a CPU bound, IO bound.
Right.
So CPU bound when you just hit the CPU, right? You do some crunching number, but asynchronous, you most likely target operations that are outbound of the CPU, which means you do maybe like database call, file system, web services.
Yeah, you're waiting on something else, whether it's a service call or mostly a service call.
Yeah, and you're going to complete at one point in the future. You don't know when, but in the old paradigm, like with the APM, we have this thing where everybody like the callback, right? You register the callback, and whenever you run it, you run it. When the operation complete, the callback trigger the notification, and you continue the operation.
JavaScript works the same way.
Yeah, it's okay programming model, but can add a lot of complexity, right? Because then we have a nested asynchronous operation, nested callbacks. So that's where, the async await came to solve all this bad headache, and the code looks sequential, but actually running asynchronously.
Right.
But back to the unbounded is that now, you can spawn many parallel computation regardless of the number of cores, right? Because like if you have a CPU bound operation, you can run the number of tasks can match more or less the number of cores, right? You have 8 cores. You can only run only 8 tasks in parallel.
Yeah. Mm-hmm.
With asynchronicity instead, this is unbounded. You don't care because somebody else do work for you, right? You push the work there. Database, in internet, on a cloud, whenever.
Sure.
Right. So that's why I like synchronicity, because even with one core machine, you can run multiple operations in parallel.
Yeah, I don't know that we're ever CPU bound anymore anyway, right? Most of the time when I look at my CPU, it's smoking cigarettes and playing poker. I got 8 cores this machine and 6 of them are asleep, right? Like there's just not much to do. To me, it seems it's always IO bound. You've called out to something that's taking longer than you think, and you shouldn't wait. Yeah. You need to keep the UI interactive. You need to send out, like, I need these 4 things from these 4 places. I should be able to send off to all 4, and I don't really care what order they come back in.
So unbounded, I mean, you have to be bound to something. And when you're asynchronous, I guess that means you send off the calls, you keep working and everything. And when everything comes back together, now something happens and your app can move on. So is that simply what unbounded means?
Well, bounded was more aiming to the fact that they're not bound to the number of cores, right? Like asynchronous operation can even 100 of parallel operation truly in parallel, regardless of the number of cores your machine. So even you have an 8-core machine or 16-core machine, you can run 100 truly parallel asynchronous operation. So unbounded.
Okay.
But yeah, definitely thinking about when we talk about the async in a way. And I remember the old time with the APM programming model when you have really to decouple the operation to the old begin and end pattern, right? How painful was the fact that the operation run here, but when is end you don't know. But how you're gonna catch the exception, something happened where you're gonna be in the callback in the beginning, especially like with a transaction. When transactions start when ended, right? So definitely the async await, kudos to Microsoft to introduce that in language. That's helped a lot.
Yeah. Did async await just get people to stop thinking about concurrency? Are there still reasons to use some of the other concurrency approaches?
Well, to me, I think it's about always a combination, right? It's not just a synchronous programming model, but different programming models can combine together. Like, for instance, if you have data parallelism, right? You have like one operation that you apply to a set of data, most likely that's going to be a task, right? Multiple tasks. So it's not just asynchronous. And that's probably most of the time is going to be an operation that's CPU bound.
Right.
So you could just crunch it, filter, project, the famous, map reduce. That's like local machine. Of course, it can be distributed. That's another topic. But even local machine, the map reduce, fork join, all this pattern, when you split, the data set in multiple small chunk of data, and then apply the operation, that's going to be, probably not just asynchronous. But definitely, you're going to put asynchronous in the beginning of the, this pipeline to load the data maybe, right? Or load the data already in portion asynchronously. So it's always like a combination, different programming model.
Man, and it's not like everything you do in a given program can be executed in any order. There are sequential steps to some things.
Yes, that's very much correct. And that's actually where my love for functional programming came to play, right?
Just going to say, I mean, in F#, it's a totally different story than in C#, isn't it?
Well, yes, it's getting better. Like the two languages start to be even. Like they add more and more feature in C#. They start to look like F#. Even the async in a way it came from the idea of the async workflow in F# is a bit different, but it's very similar the two, right? But yeah, functional programming, I think, really play a fundamental role when you write concurrent code, because functional programming guarantee that you write deterministic concurrent programs, like meaning deterministic that, when you're running concurrently multiple operation, you have this sort of like interleaving between, operation. And if you run the program multiple times, the order of execution is not guaranteed. But deterministic, whenever the order of execution change, the output remain the same.
Interesting. Okay, yeah. So 3 plus 4 equals 7, and 4 plus 3 equals 7.
That's correct. That's correct. Yep.
I like determinism. It's good.
It's good.
That's what we want. Yeah.
Yeah. But not everything is deterministic.
No, unfortunately, no, right?
Yeah.
So that is what they said, that functional programming really simplify this paradigm to write deterministic concurrent program. And really because there is some intrinsic property in a paradigm, like we already know this word, like, immutability, reference transparency, and so forth, but it really come natural with a little bit, of effort in the beginning to learn, but it definitely reward in the end.
Sure. And I've talked to lots of folks who, after learning F#, found that their C# coding style had changed, that they were writing more functional C#.
Oh, yeah. So in F# community, we have this program called mentorship, right? So every 3 years, you can be a mentor and you have a mentee, you meet here and there, you write a project. And I have a mentee a little while ago that don't have much experience in F#, but want to learn to become better C# programmer. So, kudos to this guy that really put his effort there. And actually, it was very much rewarded about that. So he definitely became a better C# programmer. He told me that. So,
but what does the language have to do with the technique? Yeah, I'm fascinated by that. Like that, why would concurrent C# or functional style C# be better?
No, I don't think that C# is better than F# as vice versa. So especially as we said that both languages start to be very similar, and we talk about functional programming as a paradigm, and both F# and C# are multi-purpose languages.
Yeah.
So you can apply object-oriented in F# and functional in C#. Now, probably in C# wasn't designed in mind with functional paradigm, so there are some situation where it requires to be extra code, but pretty much you have you can do the same thing in both languages. Like in my book, pretty much I use both languages enough as a comparison, right? It just I use to build some project using C# and some in F#. Anyways, I have both implementation available in a code sample, but just to explain some concepts. Sometimes it's better in C#, sometimes better in F#. But both languages are pretty much equivalent.
Absolutely.
For example, like immutability is one of the tenets of functional programming, and in F# is the default construct. In C# is not, so require a bit of effort, but you can do it.
Yeah, right.
The developer will be diligent, but
yeah. So the diligence versus default.
Right. You can't do that versus don't do that.
Right.
Yeah.
But what you can do, for example, that's actually pretty cool, is that you can combine the two languages, right? So now you create your object using F#, using record type, or that record type, if you're not familiar, is think about a class in C# with immutable properties as default. You can build all your model in F#, it's just a library. You reference to C# and just, there you go, you have all your object immutable.
Sure.
Yeah. And Riccardo, give us one moment here for this very important message.
When you're building an application, you need it to be fast, secure, and always evolving. With Kubernetes Engine on the Google Cloud Platform, developers can deploy fully managed, containerized apps quickly and easily. Google has been running production workloads in containers for over 15 years, and they build the best of what they learn into Kubernetes, the industry-leading open-source container orchestrator. Kubernetes Engine combines automatic scaling, updates, and reliable self-healing infrastructure with open-source flexibility to cut down development cycles and speed up time to market. Learn more about Kubernetes Engine online at g.co/getgke. That's g.co/getgke.
And we're back. It's .NET Rocks. Carl and Richard here talking to Riccardo Terrell about his book, Concurrency in .NET, published by Manning.
Good stuff there.
Yeah, and the whole first section there is free, so you can certainly take a poke around and get some ideas. Otherwise, buy the book, because books are good. There's a term in the table of contents that I don't know that I've seen before, and I'd love an explanation of it. Memoization?
Oh, yeah.
Or memoize?
Memoize, yes.
So what are we talking about when we do memoization?
Well, think about the functional way to cache a functional output.
Okay.
Now, before jumping memoization, to explain probably...
Yeah, how do you do that exactly?
Yeah, well, memoization is the fact that every function is just a map, right? Whenever you pass this input, you expect the same output. And this is called referential transparency, which is based on the concept about pure function. That's something that is very simple. Like pure function is a function that doesn't do anything outside the scope of the function itself, right? Like global variable, for instance, you write global variable is a bad thing. Everybody knows that.
Right.
Yeah.
But, throw an exception also is a side effect, right? This is not a pure function. But with pure function, there are very important properties turn out. Like, for instance, because the output never change back to parallelism mode, the order execution doesn't matter, so it can be run in parallel, right?
Right.
And because the output doesn't change, well, the value of the function can be cached, right? And memoization is a high order function, which means they take a function as argument and return a new function as output. Now, the output, this new function, the one you're going to use, and now whenever you pass an input, it just evaluate for that specific input the computation only once. And the second time, so it memorize, let's say, the output, right?
Memorize like memoize.
Right, exactly.
Leave yourself a memo. You've already figured this out.
That's correct.
Okay.
It's a great, technique in functional programming.
And so effectively a caching style.
That's correct. It's a caching. But what allows you, though, is compositional semantic, which means that now you have a function, right? You have a function really that the caching is just inside this function. So now this function can be composed together. Because the true, and open my heart here is that functional programming is just about composition. It's just about composing all these function as a building block together to solve, complex problem, which is awesome.
You know what I like about functional programming is it's very similar to electronic signal flow. I only became familiar with the whole concept of signal flow as an audio engineer because you're constantly thinking of where are the amplification points in an audio chain, where are the resistance points in an audio chain, how do you maximize that? And so you have a signal that starts at one end, comes out the other end. Richard can probably talk about the electronics thing, but it's very much the same, right? Stuff goes from inputs to outputs, And you think about that flow, and that is your sort of abstract model that you keep in your brain. Whereas object-oriented programming, it's all dependent on objects and state and what is the state of everything at a particular point in the application, which is totally different.
Yeah, I think it's far more deliberate, right? That you know what a set of inputs are, they'll give you a set of outputs, so you don't have any of that somewhere in this app something's going to be different.
Right.
When you mentioned, imperative there. So now I was thinking about, all this idea about output and a side effect. And so I want to, be clear the fact that side effects are a good thing, right? We need side effect to do something useful in a program.
They can be both.
Right.
Yeah.
So the main idea here really is that extract, what are the bad things that can happen, like the side effect function that can, do something terrible to your program. And then separate that with the pure function and a pure function, right? So when you separate the two things, now you have more control over the pure function that become more testable, and, can be memoized, can be computed in parallel. And then the function that do side effect, that can just be isolated. And that can be, like for instance, I make an example of the, when you make a back in the day with the, the old good time with ADO, when you access database with a select statement, right? You have a function that probably open database connection, open, a SQL reader, grab some data, and then you project the data to, I don't know, a person, right?
Yeah.
So there the function is take an integer, return a person.
Right.
But inside this function happen, too much stuff. The side effect to open database connection, read database, and project. So really, the idea you split that in the side effect to query the database and the function that actually project the output of the query to a person. So whenever you pass the same input to that projection function, we always return the same person. Okay. So it's just a little mindset how you can apply this paradigm. But as I said, there are definitely a lot of benefit from this approach. More testability, and of course, performance can be parallelized and so forth. So imperative programming is a good thing, right? It's always found the right tool for the job. Side effect, a good thing. But isolate side effect, control side effect, really the key to write, deterministic program.
Yeah.
Right. So what about the old parallel tools like task parallel library? What are the cases where that makes sense?
Well, it's actually become like Switzerland, the knife really can do a lot of things with that. So especially with the async and await combination, right? As I said earlier, it's about combine different paradigm. But the TPL, so we have the task per se. We just think about like a new thread, like thread from the thread from the scheduler, a task that can run something in parallel while another task is running. And then we have it like the other part of TPL, such as the parallel for each loop. Well, we can also, I say probably it's not the same, but we can also include the peeling, right?
Right.
So I think that the task part, we talk about data parallelism. Then there is a task parallelism when you compute different operation on the same or different data set. Now, the great part here is that the task, they can be combined, right? So if you break, your sequential code that do something with the, your data, most likely you can partition multiple tasks and then this task can be composed. The good thing now that because you compose, you have direct control over each task where you can apply, different strategies, different parallelism, and so forth, like building block. And actually, it came in mind, there is a great tool called TPL Dataflow. I don't know if you're familiar.
Oh, sure.
Yeah. So this TPL Dataflow, I think, is one of the Microsoft products that is so underestimated. It's such a great tool, and very few knows about it. It should be like leverage more than what I see around in the code reviews.
I agree.
Yeah. So it's about, composing multiple tasks. However, there is no built-in composition for the task in C# as today, right? There are some primitive like the task when any that, for instance, in a collection of tasks and in parallel wait for the first one to complete, or when all. And you can use this primitive sort of like combine them, or is it, continue the execution when a task complete and run the rest in parallel and so forth. But there is no primitive. So what I emphasize, and is like functional programming, is that you can abstract, the programming model to compose this task.
Right.
Like for instance, I know you use the M word, but link. Okay, we're all familiar with link. A link is, something that allows you to, work with enumerables.
Right.
But we have, the select many, but this is just a pattern. It's not really a compiler thing. Like if you write the same pattern for task, if you write like an extension method for task, they implement the select many. It just replace the enumerable with task. Just change a bit underneath it, but just the signature, enumerable with task. Then you can write your code like from T in task that is running, from task 2 in task running. So you can compose this task in a very fluent way, right?
Yeah.
Which is quite neat.
It is quite neat. Hold that thought right there, because Richard, you know what time it is now?
It must be that happy time again.
You know it, man. It's time to fix with parallel a bug results in joke my code.
Yes, it is.
Anybody who has ever done any UDP programming knows exactly what I'm talking about.
I see the Sangiovese help there.
Yes, it did. In fact, I would blame that joke on this wine right here. It's actually time to give away a DXperience subscription from DevExpress to one lucky member of the .NET Rocks fan club. Become a UI superhero with DevExpress UI controls and libraries, and deliver elegant .NET solutions that address customer needs today, and leverage your existing knowledge to build next-generation touch-enabled solutions for tomorrow. Whether it's an Office-inspired application or a data-centric analytics dashboard, DevExpress Universal ships with everything you'll need to build your best,
without limits or compromise. And check out their Dev Extreme React Grid, built from the ground up to fully support all the cool features that come with React, like the virtual DOM and state controllers. It supports master detail, sorting, grouping, paging, and editing, and you can check it out for free on GitHub. But learn more and download your free 30-day trial of DevExpress Universal at devexpress.com/superhero.
Well, all right, buddy. Who's our winner?
Today's winner, Richard, is Edward Evans.
Congratulations, Edward.
Yeah, Evan.
Golf clap for you, sir.
Yeah, Edward. I almost called him Evan because he's got
do it.
2 first names.
There you go.
Anyway, Edward just won the D-Experience subscription. That's a big pile of awesome from our friends at DevExpress just for being a member of the .NET Rocks fan club. If you'd like to be a member, go to .NETRocks.com, click on the big Get Free Stuff button, answer a few questions, and join the fan club. We have thousands of members all over the world, and every show we like to give away stuff from our sponsors. And every December, we give away a $5,000 technology shopping spree to one lucky member of the .NET Rocks fan club, but you have to sign up to win. And now it's your turn, Riccardo. If you had $5,000 to spend on technology today, what would you buy?
Oh, that's easy. So I'm a big fan of coffee.
Oh, my.
Oh, me too.
And yeah. So unfortunately, Sunday, I have a nice coffee, Jura, I think Z9, something like that. They make cappuccino, grind the fresh coffee and everything, but the cappuccino part broke. So I'm going to probably aim high and go with something like a nice coffee machine. I saw online the Jura Giga 5. It's like 5 grand coffee machine, double grinder, ceramic grinder. Oh, just a beauty. Just a beauty. Yeah.
That sounds good.
I'm sure you could spend $5,000 on an espresso machine without even trying.
Yeah.
Easy.
Oh, you're going to be way more productive too then.
Except for that whole part where you can't touch the ground. Yeah.
Yeah.
Interesting choice. The question is, do you go after the LEDs? Like, how many blinky lights does it need to be before it's a good machine?
Oh, a lot. This one, actually, you can set, your personal preference for the coffee, right? So, touch screen, of course. So it'll be under Ricky. Gonna click on the Ricky. Gonna be, my nice cappuccino in the morning, my latte afternoon. Ah, beautiful, beautiful.
Yeah, awesome stuff, and a great choice. Like, it's a fine spot to spend money.
Yep.
I love my Cuisinart coffee maker. I don't have a coffee maker built into my house like Mr. Campbell does, but I guess I don't need coffee 1 cup at a time. I usually drink a pot.
Yeah, well, and I don't drink coffee at all.
Yeah, I know. Why do you need a coffee machine built into your house when you don't drink coffee?
I'm outnumbered 1-to-1.
Uh-huh. The one who must be obeyed.
That's it.
Oh, I heard you. Yep.
She's turned the daughters into, well, one of them at least makes, I think, an iced latte almost every day. So from a point of view of why is this machine in my house, it gets used all the time. So I can't be too unhappy about it.
I was very happy when I stayed at your place several times.
It does make good coffee, apparently.
It's like the Jetsons. You're just like, make me a fresh ground cup of coffee.
Yeah.
Okay.
Well, and it's useful for me when I have guests over because it requires exactly no skill. My button pushing finger works just fine.
My button pushing finger is killing me.
That's all it takes. Yep.
Yeah.
That's what's important, actually.
All you really have to do is empty the grounds from time to time.
Yeah. Well, it's very German, right?
Right.
So it's a melee, so it does make demands.
It eats beans and it poops grounds.
You would clean the grounds container. I want my drip basin cleaned, refresh the water, time for scaling. Like, it gives you orders, which means I'm occasionally providing obscene gestures towards electronic equipment, which is odd if you think about it.
Not really for you.
No, not so much. But generally, when I gesture at electronic equipment, it's my own, and I have a screwdriver. It's like, don't make me, because I will.
I know where your power button is.
I know exactly how many screws I can remove for you, but you will still function just a bit wobbly.
Speaking of that, and I hate to hold up this conversation, but 10 minutes before the first show we recorded today, I realized that my telephone hybrid, the Telos 1+1, which I've been using for, 14 years here in the studio on .NET Rocks, to synchronize Richard's phone track with everything I'm recording, was dead. And I realized it was dead last time we did this show, but long story short, didn't get replaced. So 10 minutes, right? I'm like, hang on, I know I have another one of these around here. Run back into the storage room, and I find the old Telos 1+1 that wasn't being used and swapped it out. But in the process of doing that, I somehow tipped one of my speakers, my monitors, my Mackie monitors, studio monitors, over on a stand, and it crashed to the ground. But I was able to identify all the cables I took out and put them back in the right order and get it all working before. And the guest had no idea that.
There you go.
Yeah. So
the drama that goes on before a show happens.
But think about it, though. 14, 15 years I got out of that one piece of hardware that has been on the whole time. Like, it never gets turned off.
Yeah. Yeah, and who knows what's actually failed on it, too. Those Telos 1+1s, I mean, they don't even make them anymore.
Yeah, you're right. They don't.
Yeah.
So I have one more at home, and after that, we're done.
We're doing something else. I don't know.
We're going to do something else.
Shut down the podcast. That's it. I'm not living without a Telos.
All right, Riccardo. Sorry to dominate the conversation there in the middle. But anyway, we were talking about the task parallel library and how that you can sort of modify it with extension methods to do things that you had no idea it could do. I particularly like the idea that I can create a task and from just a block of code that isn't asynchronous, and I can run that asynchronously with await, and the original method wasn't asynchronous. I love that. It's very flexible.
It is. It's a double-edged sword. You have to be careful, but yes, it is. It is. In fact, I actually recently was doing a code review, and one ends up I had to give is that, you know, when you use the contextual keyword async in a method, you really have to do some operation that they await in a method, right? The compiler help you sometimes give you the warning that, yeah, use the async here to make the code easier, but shouldn't do anything asynchronous. So,
right.
You know, so if you check the IL generator from the compiler, it's a mess. So, yes, I mean, the compiler doesn't know. It give you the warning. It's like, hey, use your foot. I mean, I warn you.
My warm fuzzies are going away. I'm just saying, wow. Anytime I hear about a code that is in production that's a mess.
Think about if many hundred methods like this one, even the compiling time for your solution, it takes way longer than one without.
Sure.
So, yep.
Well, I think it's very interesting when you think about how functional F# is. It's still running to IL. It's being compiled into object-oriented code under the hood.
Yeah.
Oh, yeah.
So it's got to be complicated.
Indeed. Yeah. I use this tool, LinkPad, probably you're familiar with that, and I actually allowed you to run a piece of code and instantaneous the IL, right? And to compare maybe the same functionality between C# and F# and IL is compiled. They're very similar. So
that's good.
Yeah, it's good.
Yeah. But you'd expect it to be somewhat different. But I think these guys have had time to optimize everything these days. It's pretty mature stuff all around.
Oh, yeah. Bother me that they're not yet with the recursion. Like F# support the recursion, C#, no, it still scratch my head. But yeah, we will go there. We will get there probably one day.
Thumbing through your table of contents here, you do kind of stick to the .NET side, but machine learning, like all of these new data analytic techniques, I think back to MapReduce and good old Hadoop was one of my first introductions to really massive parallelism, where as many computers as I could harness for a problem, the faster I could solve it if the data set was big enough. Once I was playing with terabytes of data, it just couldn't throw too many machines at it.
Right.
And do you get into that kind of MapReduce model? Do you look at it from a Hadoop perspective, or is there more coding kinds of ways to do them?
Well, not from the Hadoop perspective, but I talk about how distributed work. So you think about, concurrency is like an umbrella, cover parallelism and so forth. Right. Really think about concurrency, is applied to your program, and then multi-program running parallel on your computer, and then multiple computer running parallel and so forth. You see how this goes until, distribute the system. So MapReduce definitely is one of these patterns that, can be applied local machine or distributed system. And in the book, I cover a little bit about leveraging the actor model to work with the MapReduce pattern. So you think about MapReduce, it's not just MapReduce, right? It's just the name, but most likely be other kind of functionality as build like a pipeline, like, maybe filter, group by, reduce, and then filter again, reduce, really start from a large data set and reduce down to, what you're looking for, your goal.
Sure. I mean, Hadoop was a great manifestation of it, but what you're talking about is also like the original paper that, was it 2004?
Yeah.
It's been around a long time, but it's just a methodology.
Yeah, exactly. It's just a part. It's just common sense. Definitely.
And I don't know that it's that common, really, Riccardo. Like, that's a tricky bit of thinking.
Well, I think that like MapReduce, one thing that maybe not a distributed system, but like at that time, we don't have the distributed system wasn't that, used as, today with the Hadoop or, Flink, all this kind of great framework, but we're using something similar, right? In a smaller scale. Like we will still get a large data set and try to make it, reduce it, filter, and so forth. So I think MapReduce was just the idea, okay, what about actually if different machine can work, distribute the work and parallelize the work and then aggregate together to different machine and so forth, like in a network. So yeah, probably not common sense, but I think that we were doing something similar without knowing about it.
Yeah, we may not have described it that way. It just gave it a name in a lot of respects.
Yeah, exactly. Sometimes we just need, a terminology to say, oh, yes, definitely, I know that.
Sure.
But I covered it a bit with the actor model, which is probably my favorite programming model.
Yeah.
So like in .NET, there is nothing built in. There is in F# there's something called the mailbox processor, which actually is an agent. It's not really an actor.
Yeah.
There's a bit different between the two types.
Yep.
And then I mentioned the TPL data flow that, again, is great for, workflow pipeline kind of, building block to run in parallel multiple operations that compose them together in this flow, but it's not an actor either, like still like in process. Right? The difference between agent and actor is that agent is most likely like a bucket in memory.
Right.
So you push messages and you run your behavior against these messages. But the mailbox or the agent, is also behavior, right? So what you can do being in process is that you can compose multiple functions and send this behavior to an agent like it was a message. So really the agents are just like in process, like in memory kind of unit of computation. Rather, the actor distributor can be in process, different machine, and so forth. But you kind of constrain the fact that you can only send messages.
Yeah.
But the good thing about this programming model, both agent and actor, is that this concept about isolation, right? We talked about mutability earlier on, how is important mutability when, especially in a multi-threaded environment, when an object being mutable, can be accessed by multiple threads simultaneously without create, unwanted behavior. On a flip of the coin, the agent or the actor use isolation, which means that agent can access, they have like internal state. They can be also mutable. It can be like, generic dictionary in .NET. It can be something that can be removed and so forth. But is isolated, meaning that only the agent can access that specific mutable object, which is, also a different programming model that I really like. And I like the idea of agent actor because the programming model fits quite well today with the distributed system. You build a system using actor, and now we give it a name that, is similar to the microservices today or, services. But you think about actor system, it can build, these services in your application, and then it make like a really cloud-friendly way today, tendency to lift everything to the cloud.
Yeah.
So it's a great program model to leverage.
Do you have a preferred library? I mean, we've done shows around Akka and Proto Actor, and I think we even did one on Orleans, which is totally Azure.
Orleans and Akka.net, yeah.
Yeah, so I did some work when I used to work at Microsoft many years ago. I do some work in Orleans a little bit, but my go-to framework these days, Akka.net. I do a lot of work with Akka.net these days too. Proto Actor definitely promising, and the guys that used to work actually in Akka.net is working in Proto Actor, and seems to be, aiming to be faster as possible.
Yep.
What's the role of async in a service? Because I think this is where people get sort of hung up. If you're responding to a service request, let's say it's web API. It doesn't have to be. It could be Node, whatever. But you're typically doing a synchronous operation as quickly as possible and sending it back to the caller. But where's the role of async on the server side?
Okay, on the server side, there are two aspects here. Like one, naturally, when you send a request to the servers, this is already like concurrent because most likely the servers handle multiple requests simultaneously, right?
Sure.
However, a synchronicity aspect is important to don't hang the server, to be scalable, right? Because now think about it. If you run synchronously a request, you have one thread that runs this request to all the cycle. But if you have like some operations such as like I/O,
long-running operation.
right? Most likely this thread is going to have some time that is idle, but it's still blocked, which means that it's consuming resources when it's not needed. So the scheduler is smart to say, okay, we're going to start with a couple hundred or threads, and then, I need more and add more and add more until you reach the point that you cannot add any more.
Doesn't end well.
Yeah, the service is not responsive, you have timeouts, and if you're lucky, otherwise, can even worse than that, you get really your system crashing. But yeah, definitely synchronicity is the key to make your system scalable. And also for companies, this is becoming more important to write applications that are asynchronous for, business perspective. Like it's cheaper to write a synchronous program rather than have that run probably and maintain the application responsive with few server than the need to buy more and more servers, right?
Absolutely.
Yeah.
Yeah.
So the way I think about it is if you have a long-running process that you need to kick off from a client, that you respond immediately and then you put something into a queue and then your long-running processes deliver that. And at the end of that, there's just another callback somewhere. So you have two callbacks on the client rather than one. The first callback is, yes, I received your message. Everything's going fine. If you want to poll for it, here's a token, something like that. Otherwise, we're going to call this other callback when everything's done.
Yeah, it's like, when you order from Amazon, right? I mean, the thread is not going to be idle until you receive your package in front of your door, right?
Now that would be funny.
Yeah, that would be interesting.
That would really push the hardware manufacturers to innovate quickly, wouldn't it?
Yeah, very expensive. But maybe, maybe a different thread in the future can spawn a drone. A drone can then deliver the package. See, that's probably the future.
Please don't close the browser. But that was Tuesday.
We lost the drone.
Are you sure you want to exit this page? Leave page.
Oh, that would be funny.
Awesome.
Yeah, they're very good. So what's next for you, man?
After this book, actually, I start a smaller version just for distributed system on a cloud, specifically in Azure. That's on my to-do list. I just start the outline and the work. So I tell you what, writing a book is a long project, right?
Yeah.
It took me a lot of months, and I was able to do it maintaining my marriage healthy, which is also...
Congratulations, man.
Yeah. Tell me about it. So
that's no small feat.
And the coffee. But yeah, definitely that's in my to-do list. Oh, I want to mention that, silent pitch here. I'm the organizer of the Open F# Conference. We did the first big conference last year in San Francisco.
Nice.
Oh yeah, that's actually was September 27 to 8, and it was a great success. A lot of people came, the West Coast vibe was great.
Yeah.
And we are doing it this year bigger and better with collaboration with Matthias. I think Matthias was in the show a little while ago that he branded with.
Yeah.
Right? Mm-hmm. And Gene from South. So yeah, that's actually it also take some work, some effort, but very exciting to do something for the community.
Awesome. Sure. Riccardo, thanks so much for spending this hour with us. It's been great.
Yeah, have a good time. Thank you, guys.
All right. And we'll see you next time on .NET Rocks. .NET Rocks is brought to you by Franklin's Net and produced by Pwop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.